Welcome to homework.
This is the answer to Chapter 14, problem number 77 from the Smith Organic Chemistry textbook. And this problem asks us to explain why the carbon-13 NMR spectrum of 3-methyl-2-butanol, which I've drawn here, why it shows 5 signals. And so we might at first glance be tempted to say that these two methyl groups here and here are equivalent, and so we would expect only 4 signals since those two would give the same signal. But if we redraw this molecule and just assign, so let's arbitrarily assign this alcohol this stereochemistry. So we'll put the alcohol on the wedge and that hydrogen on the dash there. So if we do that, and then we replace one of those two methyl groups, either one really, with something else, with X, just a generic substituent, what we see is that we actually get a set of diastereomers. So we've arbitrarily assigned this stereochemistry here to the alcohol, and so we either get X that is cis to that alcohol, or we get an X that is trans to the alcohol. Just give me a moment to finish drawing here. So cis to the alcohol up top, trans to the alcohol down here. And so these are diastereomers. So these are a pair of diastereomers. And so since replacing one of these methyl groups with an X gives us a pair of diastereomers, the methyl groups are diastereotopic. So the methyls are diastereotopic. And so remember from this chapter that if two protons or two methyl groups are diastereotopic, they're each going to give their own signal. And so that's the answer to why there are 5 signals here, because those methyl groups are not equivalent. They're actually diastereotopic. And we know that because when we replace one with an X, we get a pair of diastereomers. And that's the answer to chapter 14, problem number 77.